That's 0654 winter 2017, paper 6, 1. Yeah. We're looking at an electrical circuit here, the voltmeter and an ammeter. First thing we're being asked to do, well, this is the general experiment, is we're moving this contact up and down again. We've seen this familiar, and seen this a few times before. Just being asked to make some measurements. Nothing too ugly this time, I don't think. Okay, we've got obviously a potential difference between 1 and 2. Got 10 divisions, so each one is going to be a 0.1. So we've got 1.1, 1.2, 1.3, whoops, 1.2, 1.2, 1.3, 1.4, 1.5, that's 1.4 there. And then we also have 0.2 to 0.3, 0.4 here. Again, 10 divisions. Each one is going to now be a 0.01 division. Nothing on the half there, so we've got 0.32 amps. Okay. Just get my paper in the right place. Okay, so that's what we're being asked to do. Now it's very tempting just to go off and do everything. At this point, because you see a blank table, please don't do it straight away because you are asked to do a few things. Okay, first repeat the procedure for different positions. Her results are shown here. The students switch off the circuit between readings. Okay, now the reason that we do this is there's a couple of ways of doing this, but the best reason for changing that, for turning off the current at that point, is to avoid heating. Okay, now this is actually a practical reason, because we should know that when a wire heats up, its resistance changes. In this case, its resistance increases. That would affect the power, that would affect the measurements that we make throughout the experiment. Okay, so the reason we do that is to prevent it heating up. Now that's a practical reason, that's a physics related one. Some people worry about energy wastage. Again, that could be good, but we're really thinking about the quality of the experimental data here. Okay, so heating up, you could then say, therefore leading to the resistance changing. That would be even better. Okay, with the crocodile clip at C at the 80 centimeter mark, the glow of the filament becomes too dim to see. Okay, state how he knows that the lamp is not broken. Well, this is where we have to go back up to our data. Okay, we're looking at C 80.23. We've got if our lamp was broken, then the current through that lamp would be 0. That's how we know things are not conducting, because they have a 0 current. Well, here we clearly have a non-zero current, and so therefore it's clearly conducting. It is not broken. And so therefore a non-zero reading has been shown in the ammeter. The last thing now, kind of weirdly, last thing you have to do is go through the question of of finishing off the table. Now, I wonder how many people are sitting there slightly guilty because they didn't spot this instruction: add the unit of power to the heading of the 4th column. Unit of power is watts. Okay, I think that's something you might miss. If you were just running through the table, maybe a bit flustered, maybe not quite paying attention to what you're doing, you might forget that W. The instruction is there. Okay, it does tell you what to do. Okay, power is measured in watts. You're then asked to calculate the missing power values. I think most of you are okay with that. But just to show you my work, I did my working down here. 0.448, 0.234, 0.168. If you look at the fit with the pattern that is established in the table above, so they've gone for 2 decimal places, go for 2 decimal places here. So I've turned my 0.448 into 0.45, 0.23, 0.17. Okay. Now, we're not actually asked to plot a graph here. Well, we're not actually plot one, we're asked to sketch. Okay. The student suggests that the power of the filament lamp is directly proportional to the current flowing through it. Okay. Sketch on the axis provided the graph the student would expect to see. So this is not what the student's data says, okay, but it's what the student would expect to see. Directly proportional means 2 things. Means that we've got a straight line, and not just any straight line, but one which goes through the origin. It must go through the origin. So if you drew a straight line up here, you probably get a mark for a straight line, but you would miss the mark for the origin. Why? The point here that he is suggesting, and bear in mind, this is a wrong suggestion, okay? But he is suggesting that P is directly proportional to I. And what that means is if I goes to 2I, therefore P goes to 2P. And that's why we have that proportionality. We'll notice if I equals 0, P also equals 0, which is why we go through the origin. All right. We're being told not to plot a graph, and being asked to show the results, and table 3.1 don't support his suggestion. What I've done is taken an example of the data. Okay, I've taken 2 of the data points, and I found this quite hard to explain when I was doing it. I took the top data point and the bottom one, I think, and I said, well, if this is the case, yeah, if it's the case that power is directly proportional, then if I take the ratio of these 2 values, then the ratio of these 2 values should also be the same. Okay, so whatever I do to the current, so in this case, go from 0.23 to 0.32, then 0.09 should do the same thing. The reason I chose this one is actually because it's quite a nice clean factor of 5, right? Power goes up by a factor of 5, so does current go up by a factor of 5? Well, no. All right, and so therefore they are not they're not directly proportional. Just for those of you who are interested, okay, if we did have this, it's quite a hard question, this P and I, yeah, okay, we've got the equation P equal to IV, but we've also got another equation P equal to I squared R. Yeah, P equal to I squared R. Again, this is not one that we are meant to really use, but this is the relationship we get. Actually, what would happen, P is proportional to I squared, which means if I goes to 2I, I squared, therefore goes to 4I squared, so therefore P will go to quadruple P, all right, which is kind of what you see in the data, all right, but again, you're not being asked for this, it's just for those of you who are interested.